we're going to look and understand that the volume is the space occupied by a 3D shape. And yesterday we looked at the formula for finding volume, and the formula is?
Length times height times width.
Good, okay. Sometimes we don't need to use the formula. What could we do instead?
Count the cubes.
Count the cubes, well done. So for this question, if each cube had a volume of 1 centimetre cubed, find the volume of each solid. So what's the volume of that shape altogether? 3
centimetres cubed.
Good, because we've got 1, 2, 3, so 3 cubes, they're centimetre cubes, 3 centimetres cubed. Good. What's the volume of that one? When it comes back, there we are.
6 centimetres cubed.
6 centimetres cubed. And what's the volume of that one?
6 centimetres.
6 centimetres cubed. Okay, good. Okay. So, have a look at the next ones. Doesn't help when the road keeps going off. Right, have a look at those shapes and work out the volume. So, count the cubes, work out the volume. There are different ways of calculating. So in this one, you could actually work out that cuboid and then add that row onto the end. It's up to you. Whichever way suits you best. You can do it in slices that way. Whichever way you think your maths brain will cope best with. So, what is the volume of that shape?
28 centimetres cubed.
28 centimetres cubed. Yeah, so we've got 6 there, 4 there, 6 fours are 24, and then 4 more on the end, 28. Well done. Good. Was that the same method you used?
I did the formula,
Yeah.
and then took away 4 because I knew 4 was missing.
Added 4.
Oh, sorry.
Added 4. Yeah, that's good. So you used the formula for that bit, for the cuboid, and then added those 4 onto the total. Good. Well done. This one is probably easier to count. You might want to use the formula for, oops, gone off again, for the bottom bit, but it's up to you. What do you think? How many cubes are there?
11 centimetres.
Right, let's check. So we've got 4 by 2, which is 8, 9, 10, 11. Good, well done. Okay, what about this one?
12 centimetres.
12 centimetres cubed. Right, let's have a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good, well done. Right, this one's a tricky one, isn't it? Whoop, board keeps going off. Right, you could do it in layers. So that chunk, if you imagine you've got a sharp knife and cut it like a cake, that layer, that layer, that layer, that layer, it's really up to you. You split it up in the way that you think is best. What do you think the volume is of that one?
47
centimetres cubed. Okay. I haven't calculated it, I'm going to take your word for it. It was certainly a lot bigger. You could see straight away, couldn't you, it was a lot bigger. Right, if we were to put those in ascending order, what would it mean? What does ascending order mean?
Would it mean smallest to largest?
It does, it means smallest to largest. It means going up in order, smallest to largest. So if the question said put it in ascending order, you'd start the smallest, next biggest, next biggest, next biggest. What about if each cube wasn't a centimetre, but it was a millimetre? Would this affect your answer? Would this still be in the same order?
No, because they're still the same amount. It would affect it because it would be in millimetres, but...
Well, yes, it would, but would this still be in the same order?
Yeah.
Would the smallest one in the centimetre, if it was centimetres, still be the smallest if it was millimetres?
I think so.
Yeah, it would. Yeah. The unit will be different. So obviously the shapes will be smaller, much smaller. But if it's the smallest in terms of centimetres, it's going to be the smallest in terms of millimetres. What about if each cube was a metre? And they were huge cubes. Would this still be in the same order?
Yes.
Yes, they would. They'd all be a lot bigger, but they would still be in the same order. One of them would still be smaller than the other, and then the other, wouldn't it? Yeah? Okay. Right. One more slide to have a look at. How many cubes are used? What is the volume of this shape? If all the cubes are 1 centimetre cubed, how many more cubes would you need to make this into a cuboid? What would the volume of the new shape be? Okay. Now, this is very similar to the one we looked at earlier. And you could, if you've got a very sharp knife, you could slice it down there and work out the volume of that bit, work out the volume of that, and the total volume would be 28 centimetres cubed, yeah, because we've got 6 there, 4 there, 6 fours 24, and then 4 more added on. Good, like the shape before. So, how many cubes are used? 28, good. What is the volume? Can we all say that really loudly for the camera, please?
28
centimetres cubed. Good, that's better. Children at home need to hear you as well. How many more cubes would be needed to make this into a cuboid?
Would it be 4?
It would be 4. If you put 4 more cubes along there, that would make it into a cuboid. What would the volume of the new shape be?
32.
Good, because it would have 4 more cubes, wouldn't it? But also the new shape, the new cuboid, you could work out, if you didn't know what we know already, you could use the formula.